Hello, welcome back to Educator.com and welcome back to AP Calculus. So today we're going to start talking about the limit of a function. Very, very important topic. It is absolutely the foundation of all of calculus. Let's jump right on in. Okay, so in the first few lessons I mentioned that given some f of x, the derivative involves some limit process. So let me actually see here, what shall I work in? I think I'll work in blue today. So, in the first few lessons, I mentioned that given f of x, the derivative, which we symbolized with a little prime symbol, the derivative f prime of x was found as follows. Took the limit as h approaches 0. Sorry, let's go ahead and put f prime of x is equal to quotient f of x plus h minus f of x over h. So here, so basically, once we form this quotient, we simplify it. Once we form this quotient and simplify algebraically, or whatever else that we need to do, it's going to be algebraically, we get some function. Let's call it g of x. So when we form this quotient, we simplify it, and that gives us some function of x. Then we take the limit. Then we apply this thing. So we end up taking the limit as, as h goes to 0 of some g of x. More generally, we want to be able to handle things like this. So more generally, when we take a derivative, we're going to be taking limits. But that's not the only time that we're going to be taking limits. So we want to be able to handle limits whenever they come up, not just in the context of differentiation. So more generally, we want to be able to handle any function, the limit as x approaches some number of any function f of x, whenever it might come up, whether it's in the context of derivative or not. So this is what we want to know about, and this is what we're going to do for the next couple of lessons. So what this says is as follows. Says, okay, so again, let me rewrite it so we have it on this page. The limit as x approaches a of f of x. So this symbol says, given some function x, given some function f of x, what happens to this f of x as x itself gets closer and closer to some number a, And a could be infinity, so x could go off to infinity, and we ask ourselves, well, if x is going to infinity, what's the function doing? As x approaches 5, what's the function doing? How is it behaving? Is it oscillating? Is it going off to infinity itself? Is it getting close to a number? That's what we're asking. So in other words, excuse me. In other words, Well, y equals f of x, right? So we know that when we have f of x equals x squared, y equals x squared, f of x and y are essentially synonymous. So for y equals f of x, so again, what this says, what this symbol says is as x gets closer and closer to a, does y get closer and closer to some number itself? To some number itself? Does it go off to infinity? Does y go off to positive or negative infinity? Does y oscillate back and forth between, two numbers? Does y oscillate? Well, let's not use the word, well, that's fine. Does y bounce back and forth? Back and forth between two numbers? So what does y do? That's what we're asking. That's what this symbol says. As x gets closer to some number, what does f of x do? In other words, what happens to y? What happens to y? As it turns out, all three of these things happen. Sometimes y gets close to a number. Sometimes it goes off to infinity, positive or negative infinity. And sometimes it just oscillates between two numbers. So, turns out all of these happen depending on the function and depending on the number you're approaching, depending on a. Depending on what f of x is, depending on x and f of x, and depending on a. Okay. So, I'm going to describe this limit concept. So, I'm going to describe this limit concept by looking at the graphs of several functions. By looking at the graphs of several functions. Because I want you to have an intuitive understanding of what a limit means. I want you to have an intuitive understanding. I think understanding is probably not the word I want to use. I want you to have an intuitive feel. Feel for what the symbol limit as x approaches a of f of x means. If you have an intuitive understanding, then any math that we do on a formal level will make sense. But if we just throw out some definition, some formal definition involving mathematical symbols, no matter, we can explain it, but you need to get a feel for it. It's very, very important. The intuitive is actually more important than the formal mathematical at this level. So, as a matter of fact, let me go ahead and take just a second to discuss this notion between formal and intuition. Nowadays in calculus courses, in AP Calculus, I believe that most classes, when they talk about this idea of a limit, they introduce the formal definition of a limit, and you may or may not do it in your class. I'm not exactly sure. Now, it's my personal belief that at this level, when you're just doing calculus, multivariable calculus, linear algebra, and differential equations, your first exposure to these things, you should not be exposed to formal definitions and what we call epsilons and deltas. it's more important that you understand what's happening intuitively so that you can actually manipulate your mathematics based on what you understand rather than trying to, fiddle with, really intricate formal definitions. For those of you that go on into mathematics, you're going to end up taking a course called analysis, where you go back and you revisit calculus, but instead of actually doing computational problems, you actually prove why it is that you can do the things in calculus that we're going to do for this entire course. So you're going to see the formal definition. Again, it's going to depend on your teacher, the extent to which they actually want to emphasize it. But it's my personal belief that it doesn't belong at this level. And for that reason, I'm not going to present a formal definition. In some of the problems that I do later, I may mention it in passing, but I want you to have the intuitive feel before we do a formal definition. So anyway, so let's look at the following function. So let's look at y equals x squared and ask the following question. What is the limit as x approaches 3 of f of x? Or, same thing, because f of x is x squared, what is the limit as x approaches 3 of x squared? So what we're asking is that x gets close to 3, what does x squared do? Okay, we write that down. So what we are asking is, as x gets closer and closer to 3, closer and closer to 3, what is happening with y? What is happening to y? You know the answer already, but let's take a look at it.